Nuclear Physics Project by George Pope and Haran Wen.
Fundamental particles. Standard model. The Standard Model is a model which explains how basic parts of matter interact. It was based upon these subparticles. Hadrons and leptons. Hadrons are heavy particles which are split into mesons and baryons that interact with strong forces. Leptons are lighter particles which interact with weak forces and are basic building blocks of matter. Muon and the neutrino. Muons are one of the necessary building block particles, which is a massive subatomic lepton particle which has a neutrino. It has no net electron charge. When a muon neutrino interacts with a nucleus, it can produce an energetic muon which travels only for a very short distance and emits a sharp outline cone of radiation called Cherenkov, which can only be detected by a photomultiplier tubes. Quarks. Quarks are one of the basic building blocks of matter. There are 6 types of quarks, and they are up, down, strange, charm, top and bottom. From each of these they can create from the table listed. They can create different types of particles varying on each quark, e.g. the baryon protons and neutrons are created by up and down quarks, as shown. Weak interactions. How beta decay works with quarks is that within the neutron there are up-down quarks. One of the down quarks turns into an up quark because the down quark has a charge of -1/3 and the up quark has a charge of 2/3. There is a virtual W particle which takes away the -1 charge and therefore is conserved overall. The new up quark then rebounds away from the W particles, then the neutron has now become a proton. Then an electron comes out from the virtual W boson, then both protons and electrons move away from each other. The Rutherford model and the gold foil experiment. Introduction to the gold foil experiment. When JJ's plum pudding model was given to Rutherford, he saw it as incomplete and he found that it had lots of faults, and he wanted to set out and make his own gold foil experiment, and he aimed to show the full concept of a nucleus atom. He bombarded thick gold foil with alpha particles. On the bombardment, the alpha particles scattered in different directions and angles. These were detected by a fluorescent rotatable detector which has a microscope and a screen coated with zinc sulfide. Also, the environment was contained in a vacuum to ensure there is no disruption with the air particles. He observed that almost all particles did pass through the foil, but some alpha particles had been deflected off at different angles, and very few alpha particles bounced back after hitting the gold foils. His conclusion from the test: because most alpha particles pass straight through the gold foil, it shows the space within the atom is a vacuum. Also, the deflection bouncing back of alpha particles shows that they have approached some positively charged region, and the very few that didn't go through the deflection process showed that the volume of the nucleus is very small. Here's a diagram of the atom. There's a nuclide representation. A hadron is any particle which is made from quarks, antiquarks, and gluons, like protons. Isotopes is the nucleon number which varies on the same type of atom due to the different number of neutrons. Isotopes are important because it is used in a wide variety of things, such as cancer treatments, smoke detectors, fingerprinting, and forensic analysis. And these all enable new sources of energy, such as nuclear fission and many more. It is important, especially for carbon dating, like the decay of carbon-14 to carbon-12. Because of this, it helps scientists to measure ages of objects which were alive at some time in the past, like fossils. The amount of protons and neutrons in the nucleus, e.g. hydrogen-1, carbon-12, and oxygen-16. The difference between nucleon number and nuclide is nucleon is that the nucleon number is the amount, whereas the nuclide is characterized by the constitution of its nucleus. The amount of protons in a nucleus of an atom. When they vary, they are different types of atoms. Hydrogen is 1, helium is 2, lithium is 3, and beryllium is 4. The number of protons can be determined through the proton number. Alternatively, nucleon numbers minus the number of neutrons is proton numbers. The neutron number can be found by the nucleon number minus the proton number. A nuclide is a specific type of atom which is shown through the number of proton and neutrons. Some examples may be hydrogen 1, carbon 12, carbon 14, oxygen 16, oxygen 18. Notice how there are two types of carbons. They are called isotopes of each other. Detection. Types of nuclear radiation here. Alpha, beta, and gamma. The Geiger-Müller tube. It is several metallic tube filled with argon or another noble gas mixed with a small amount of alcohol vapor or bromine gas. What detects the radiation is the argon gas, and if it goes in contact with radiation, it ionizes it, and the remaining electrons create an electric current in the metallic tubes and flow to the output. Ionizing power can be stopped by the columns, and they relate to each other because the stronger the ionizing power, the more penetrative you can go through in the stopped by column, i.e. the thicker the material. The electric charge can be stopped by the column can lead to methods of determining the types of radiation ejected from a source, because the stopped by column's charge may tell us the charge of the radiation source. If the radiation that is ejected is positive, it will attract a negative stopped by material. Nuclear reaction. Alpha decay. Both the mass number and the atomic number are conserved in alpha decay. The equation for decay would lose, lose 4 to alpha, which is atomic mass number 4 and proton number 2. Beta decay. Positive. Both the mass number and the atomic number are conserved in alpha decay. The equation for decay would lose atomic mass number 4 and proton number of 2, e.g. that. Negative. Beta negative decay is an energetic negative electron is emitted, producing a daughter nucleus of one higher atomic number and the mass number is conserved. Gamma decay. The nucleus goes from high energy state to a lower energy state through the emission of electromagnetic radiation. The amount of protons and neutrons in the nucleus is conserved, so in other words, the parent-daughter atoms are in the same chemical element. The electron volt is a unit of energy in nuclear physics. An electron volt is the kinetic energy gained by an electron or charged particles when passing through a voltage difference of 1 volt in a vacuum. Thank you.